Okay, in 5.2 we're going to be looking at polynomial functions and what exactly makes a polynomial and then how to evaluate with them and whatnot. Now we've done some bits of this before, but we're going to get a little more specific. So we need to talk about what a polynomial is and what it isn't. Okay, a polynomial, poly means many, is a monomial or the sum of monomials. Okay, so something that looks like this. So we've done quadratic, that was a polynomial function. So we have in these a couple of different vocabulary words, such as the leading coefficient, the degree, and something called a constant term. So when a polynomial has a degree of 0, degree being the highest power within all of the monomials summed together, a degree of 0 is just a constant term. That means there is no variables. So for instance, y equals 7, or f of x, this function notation. Remember, f of x, not f times x, f of x, same thing as y, is equal to 7. Okay, a linear function has a degree of 1. So something like y equals 2x minus 3. It has a degree of 1 because x to the first power is the highest exponent. Where our leading coefficient is 2 in this case. It is the coefficient that is attached to the highest power. Okay. All right, then we get to quadratic, meaning the degree is 2. We just finished that unit looking at polynomials that have the highest degree of 2. So an example is f of x equals negative 11x squared plus 3x minus 5. And then we've got the last two. Now you can go higher than a degree of 4, and we would just call that a 5th degree, a 6th degree, and so on and so forth. So we have cubic functions, which means the highest power, the degree is 3. A quartic, where the degree is 4, and so on. So as soon as I get higher than that, I would say a 5th degree polynomial function, which means an x to the 5th is the highest power. Now if you look at all of these, you'll see that they have some things in common. So what makes them a polynomial is the fact that they have all whole number exponents that are positive. There's no fractions within the exponents, meaning that we don't have x in a denominator. Okay, it doesn't matter what the coefficients are. They can be fractions and negative and so on, but the exponents themselves cannot. The exponent is always a numerical value, meaning it is not, say, like x to the y power or something like that. So down below, a function is not a polynomial if it has negative exponents. Okay. So x to the negative 2 is not considered a polynomial because x to the negative 2 is the same thing as 1 over x squared. So that puts x in the denominator. Okay, a function is not a polynomial if the exponents it has exponents that are not whole numbers. So x to the 3/2 power, x to the 0.2 power, and so on. They're not whole numbers. It is not considered a polynomial. Okay, so it's not a polynomial if the coefficients aren't real numbers. They can be coefficients. I think I spelled that wrong. So i's, imaginary numbers, are not considered polynomials. They can be fractions, they can be decimals, but they must be real numbers. So no imaginary, no i's. Okay, and last but not least, a polynomial or a function is not a polynomial if the exponents are a variable. So y equals 3 to the x power is not a polynomial. X to the 3rd is. So really a polynomial is any combination of x terms where all of the powers of x are non-negative integers. Integers meaning they're whole numbers, but they're non-negative. All right, so let's look at these examples and decide whether they're a polynomial or not. And if it is, we're going to state the degree, so that's the highest power that we see, the type, so is it quadratic or whatnot, and the leading coefficient. So let's look at the first one. All right, so I see all of the exponents that are attached to the x, and all of the terms, if it has an x, they're whole numbers. So we've got an x squared and an x to the first, so they're whole numbers. They're non-negative, and there's no exponents that are variables. We don't have any negative exponents. So this one is, okay, and its degree, the degree is 2 because it's the highest power. We call that a quadratic. That's what we did last unit. And the leading coefficient, oh man, I can't spell today, sorry guys. Is the number in front of the highest power. So that in this case is 7. Let's compare that to B. Okay, the first term does have all of the same qualities that the part A had, but then I look at 6 times the square root of x. The square root of x can be rewritten as x to the 1/2 power, which is a non-whole number. So this one is not a polynomial. All right, so now I want you to look at C and D. Okay, so C, every term has non-negative exponents. They're whole numbers. There's no non-real coefficients, and there's no exponents that are a variable. So this one is, okay, so we've got another one that works. So we've got a degree in this case of 4 because the highest power, so we've got a quartic. It makes you think it's a quadratic again because we see the 3x squared first, but you have to look for the highest power within the whole thing. Typically we will write them in descending order, but this one is not. Okay, so we have a quartic function, meaning that it has a degree of 4, and the leading coefficient is 8. All right, so again, we're going to compare to that the next one. The first two terms work, and then I get this weird 4 over x, which can be rewritten as 4x to the negative first power. That is a non-whole, or it's a whole number, but it is not positive. Okay, so no negative exponents. So again, this one is not a polynomial. All right, so something that we have done before already is just plugging in numbers, evaluating. So if I said that I wanted to evaluate f of 3, so we're plugging in 3. So when I write it this way, this means plug in 3 for x. Okay, that does not mean f times 3, it means plugging in 3. So I'm going to plug in 3 where I see an x. And directly evaluate. So I've got 3 to the 4th is 81. Okay, so I've got 81 times 2. So 81 times 2 is 162. 3 to the 3rd is 27. 27 times negative 5 is negative 135. Minus 4 times 3, so that's minus 12 plus 8. And I get 23. So that means f of 3 is 23 in this case. Now this can be a little bit cumbersome, right? Plugging in all these numbers, and it gets hard with order of operations, and it just takes a little bit longer. So another way that we can do this is something called synthetic substitution. Okay, so I have it set up here so you can see what it looks like. I'm going to take the coefficients of all the terms. If I'm missing, so we're going in descending order from highest power to lowest, okay? If I am missing any, I have to put a 0 in its place. So if you look at this example here, I am missing the x squared term. So I'm going to put a 0 in its place. So if I make a little bracket here, I'm going to put my coefficients 2, negative 5, 0 for the x squared, negative 4, and 8. And then on the outside, I'm going to put the number I want to plug in. So how I do this, I'm going to just drop down the first number, and then I always, whatever's on the outside and what's down here is I'm going to multiply the 3 by that number, and it goes underneath the next piece. So I'm going to do 3 times 2 and put the 6 in. Then I'm going to add what's inside to get 1, and then multiply again. So I'm going to multiply 3 times 1 to get 3, and that goes here. Add to get 3. 3 times 3 gives me 9. Add negative 4 plus 9 to get 5. 3 times 5 is 15. Add 8 plus 15, and I get the 23. So I still get the same value. So we can remember this as drop mama. So you're going to drop the first term, multiply by the x term, add, multiply, add, and you do that as many times as you need until you get to the end. So I'm going to have you try. We're going to do 1 or 2 together, and then I'm going to have you try. So again, I'm going to take my coefficients. So highest power, 3, is the leading coefficient. To the third power is the 2. To the second power is negative 12. To the first power is negative 8. And no power is 6. So I don't need any zeros in this case. And I'm going to plug in 2. So I'm going to drop, multiply, add, multiply, add, multiply, add, multiply, and add. So that means f of 2 for this function is 6. And if you need to check it for yourself, plug in 2 into the equation given to you. I'm going to do one more of them for you, and then I want you to try the last one yourself. Alright, so in example 3, we're going to plug negative 1 into this function. So, starting at the highest power, I've got 5, then to the third power. Now notice I'm missing the second and first power, so I'm going to do 0 for the second power, 0 for the first power, negative 4. So I'm going to drop the 5, multiply, add, multiply, add, multiply, add, multiply, add. So that means f of negative 1 is equal to 4. So now I want you to try the last example, B.